Today we are writing equations for lines of best fit. Since these are linear equations, we are going to use the formula y equals mx plus b, which is our slope-intercept form, okay, where m is our slope and b is our y-intercept. Okay, so on these graphs, we are going to find where the line crosses the y-axis. Okay, in this first one, we're going to take a look right here, and it's right between 2 and 4, so that's going to be 3 is going to be our y-intercept. And then let's go back and read the whole problem here. It says the scatter plot shows the average annual stock price for a company. Write an equation in slope-intercept form for the line of fit that is drawn. Then interpret the slope and the y-intercept. So y-intercept is 3, slope is, let's see, crosses perfectly right about there, and then right here again. So we've got from 3 up to 8 is 5 and over 2. So a 5 over 2 is our slope. So my equation would be y equals 5 over 2x plus 3 because my y-intercept is 3. Now that y-intercept, what that means is in 2010, because it's years since 2010, so 0 years since. So 2010, it was $3 per stock. The stock price was $3. Okay. Then the slope means that the price of stock increases $5 every 2 years. Okay, so that slope is an increase of $5 every 2 years, and it is positive slope because it is increasing. Okay, let's take a look at number 2 together. The scatter plot shows the response time for emergency service and the distance from the accident. Write an equation in slope-intercept form for the line of fit that is drawn. Then interpret the slope and y-intercept. Okay, so this one, that line's going to cross right there at 0, 0. So this is a proportional relationship. And then I can see that it crosses perfectly at several places. So this counts by 0.5, so it rises 0.5 and over 1. So it goes up 1 and over 2, which would be a 1 over 2 slope. Okay, and 0 is my y-intercept. All right, so distance from the accident. So at the accident, the response time is 0 minutes. Okay, but for every 2 miles from the accident, the response time increases by 1 minute. Okay, so an increase in 1 minute for every 2 miles from the accident is what those mean, which means your equation is y equals 1/2 x plus 0. We don't have to write plus 0. Okay, there are 2 more just like those that you can give a shot on your own. Okay, and then these ones are a little bit different. It says the scatter plot shows the relationship between the cost and the number of dozens of hats produced. Write an equation for the line of fit, then use it to make a conjecture about the cost of producing 5 dozen hats. Okay, so again, y-intercept is right here at 80. My slope crosses perfectly here. It goes down 10 over 1. That's maybe not exactly right. This one looks 80 down to 10 is down 70 over 6. 70 over 6 looks like maybe a better slope than 1 over 1, because as I follow that 10 over 1, it doesn't follow it perfectly. So I wanted to look for one that was a little bit better. So 70 over 6 is going to be a little bit more accurate there for my slope. So my equation is y equals 70 over 6 x plus 80. 70 over 6 does simplify, so y equals 35 over 3 x x plus 80. Okay, and this means that when 0 hats are sold, the cost of production is $80. Okay, and for every 70 hats sold, or sorry, every $70 a production, there's 6 dozen hats that need to be sold. Okay, and then it says use this to make a conjecture about the cost of producing 5 dozen hats. Well, if X is my dozens, I can substitute Y equals 35 over 3 times 5 for 5 dozen plus 80. And this would tell me that it would be about $138.33 for the cost to produce 5 dozen hats. Oops, this is a negative slope. Okay, negative slope. So we actually need to go back and type in negative and then plus your 80. So $21.67 is actually $21.67. Now, I knew that something had gone wrong because when I take a look here at dozens, 5 dozens, on my graph, it's just above 20. Okay, barely above 20. So I knew 138 couldn't possibly be correct. Okay, so I went back and double checked. I realized, oh, this is a negative slope. So I fixed that in my equation and then recalculated. Okay, so always double check your work. Don't just assume that it's correct. That's why we have those checks and balances. Okay, so let's do one more like this together. The scatter plot shows the relationship between the number of pounds of honey produced each year and the number of bees. Write an equation for the line of best fit. Okay, so this is 24. We're counting by sixes here. It's about 28. So 28 is going to be my y-intercept. My slope is going to be, so I go from 30 to 36, 6 over 5. Nope. 6 over 7.5. We go up 1 block and over 1, 2, 3. So that's from 2.5 to 10. So that's 7.5. So 6 over 7.5, which simplifies to 4 over 5. X equals my Y value. Okay. Then it says use this to make a conjecture about 13,000 bees. So these are in thousands, so we're going to plug 13 in. So Y equals 4/5 times 13 plus 28. And this is a positive slope, so Y equals 38 and 2/5 pounds of honey. Okay? And if we take a look at our graph here, 13 would be right about here, and it's right above the 36 mark. So that looks like a pretty good estimate there. Okay? You can try these two on your own here.